framework. Hot chocolate, Azure Cosmos DB. Nappa. Entity framework, power tools.
Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shiro Dance.
Grace Lanston.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Hi, here we are again. We're back with another .NET Data Community Stand-Up. Shai and myself here from the .NET Data Access team, and Shai is basically going to talk to us about how LINQ works, Language Integrated Query, in .NET C#, and we're going to use EF Core as the basis for that, because that's the primary LINQ provider that we work on. But some of it will be relevant to any LINQ provider. Some of it will probably get quite complicated, but hopefully there's enough there that to give people an idea of the understanding of the basic concepts, which are really interesting to learn and not always immediately obvious when you start using it. So I'm really looking forward to this, and hopefully you guys are too. No State of the Unicorn this week, because I was looking through and there's not much changed from last week. I will say EF Core 8 Preview 1 and .NET 8 Preview 1 are both out now, so you can go try out new features on those. And we have some getting started docs on that as well. Well, what's new docs more than getting started? They're more than getting started. Anyway, and then also EF Core 703 is out now. And that has the majority of the patches that we've done on 7.0. So that's a really important patch release. 7.04 should be coming out next week, but that's fewer patches than 7.03. 7.03 was the one where we were able to get the most stuff in after the initial release. And then, of course, there's always the daily builds, which give you the most up-to-date stuff. It's always well worth trying stuff out in the daily builds. When we do bug fixes, we make sure they go in there, so you can use those even if it's only temporarily while you wait for it to come into some other release. Okay, enough of that. Let's go talk about LINQ. Shai?
Okay, so here, let me add this
slide thing. This is going to actually have like a PowerPoint presentation as well, which is something we never do, but it still will be interesting. The fact that there's a presentation does not mean this will not be interesting. That's just the thing I wanted to say. So yes, as Arthur said, this week, the idea, I've been actually wanting to do this for a very long time. The idea is to do a deep dive into how LINQ works and specifically discuss some aspects of how EF Core works when it processes your queries, right? So this is definitely, how the sausage is made kind of, session. This is not something that's immediately useful for you. We're not going to discuss a cool new feature that you can use in your programs. That's not it. But I do believe there's definitely some aspects which are going to help you. There's hopefully going to be some aha moments there where you're going to, understand, oh, so this is how it works. And it's actually going to help you write, better queries, or at least understand how to avoid certain mistakes. So I really believe that this is useful to anybody using a LINQ provider such as EF Core, but we'll see. I'm looking forward to getting some feedback.
Ask your questions. We'll take some of them, when they come in. Others, there's a thing in the StreamYard that we use where I can mark them, and then we'll come back to them later. So if we haven't answered your question right away, don't worry. We'll come back to questions later. But yeah, sure, ask them in the chat.
Exactly. I'll try hard to make some some stop points in the middle, and we'll handle some questions. So definitely write them, and we'll try our best. So first, I want to do a little bit of disambiguation. So what do we mean when we say LINQ? So LINQ is a very famous C# thing, language integrated query. Usually, when people talk about LINQ in the world of C#, they're referring to this very simple thing, right? Let's say you have an array of blogs or anything else. It doesn't matter. LINQ is a super cool thing where you can use functional style operators, like a very functional approach towards to do certain sequence operations or whatever you want to call it. So you have a catalog of operators like where, which filters, and you've got order by, which sorts. We call this functional programming because these operators typically get another function as their parameter. They get lambdas. So it's a functional kind of approach where we're passing around functions and so on. Our starting point here is blogs. We can call this our root, the root of data. And then we, continuously compose more and more operators. And in the end, there's some terminating thing, operator like toArray, that's going to cause this whole expression to actually get evaluated. So one interesting part of LINQ, as I'm discussing it now, is when I do this where, nothing actually happens, right? It's a lazy evaluation technology. When I do this, nothing happens. It just composes the operation, and then this composes another operation on top of it. And when we evaluate it, then and only then does the entire thing get evaluated. And this has all kinds of interesting properties. Of course, I don't even need to run this. I hope everybody knows enough about LINQ. This is basically the way it works. Now, the important thing is to realize that these operators that we see, as you can see in my documentation here, they're over something called an IEnumerable. So IEnumerable is the abstraction in .NET to refer to something you can enumerate over. What does that mean? It could mean anything. It means the data is not even necessarily in memory, like as an array. It could be like coming from someplace in the network. We might not have the entire stream in memory at the same time. Again, it's very, very lazy, right? But the important thing is that these operators actually do operations in .NET. Now, I'm going to do something maybe a little bit ambitious. I'm going to F12 into this. I'm going to go into the sources of what where is, just so that because we're going to contrast this with what happens later. Now, it doesn't exactly matter how this is actually implemented. You see that internally in .NET, we're now inside the .NET, BCL, inside the .NET sources. There's a where enumerable iterator, and if I look into it, I'll see that at the end of the day, there's going to be something that goes over the data here, like enumerates over the data, right? There's an enumerator underneath this that we get out of this enumerable, and it's going to activate, it's going to call the predicate. This is the function, that lambda that we passed it. We're going to pass it each item, and if that thing returns bool, then we return it. Otherwise, we just continue moving to the next thing. So this is how where is implemented. It actually looks at the data one by one, calls your function, returns it if it returns true, and doesn't return it and moves on to the next thing if it returns false. Makes total sense. It's totally, it's totally, what you would expect. Nothing to see here. Move along. Now, when you move to EF Core, you have something. Now we're moving to another aspect of LINQ, which I think is much less clear to most people, right? Everybody knows what I just said. Now, in EF Core, I have a blog context. I create and I see the database. I'm not even going to run this query so much, so it doesn't really matter. Let me make this exactly as the other one is, just for symmetry's sake or whatever. We have something that looks very much like the above. There's the same where and there's the same order by. The starting point is different. This is very crucial, right? So the starting point is no longer an array. It's what we call a DB set. So EF Core defines something called a DB set. We can call this our query root. This is the thing that represents the data that I'm going to apply my operators on. So this is the query root, a bit like how blogs here was my, the root of the IEnumerable thing. But if I look over where, then something else shows up in my documentation. This is no longer IEnumerable where, it's actually iQueryable where, right? So now we have a completely new concept, which I don't think most people here are actually aware of, even though you use it every single day with EF Core. iQueryable is you could think about it as something similar to IEnumerable. What it means is it's not a stream of data that we can just enumerate now. What it is basically an abstraction over something we can query over. So it's a thing over which we can apply stuff like where, order by, sorting, and all those base concepts. But EF Core doesn't take any data and actually, oh, I'm kind of stuck here. It doesn't actually take data from the database and apply the operators, right? The whole point here, we don't want to take the blogs in the database, which is, let's say, a database table. We don't want to download all of that and then apply the where here in .NET via the code that we just saw, right? In the .NET sources, right? That would be horrible for performance reasons. What we want is for this whole thing to get translated into SQL and sent to the server, and then the server will evaluate this whole thing, which we express here via these operators, and send us back the results. I hope that's clear. That's not a trivial thing, what I just said, right?
Yeah, that is the critical thing that you really, that's one of the aha moments that, I mean, for me, it's many years ago now, but I remember having that aha moment, like, oh, this isn't getting executed. I'm not writing code here that is going to just get executed. It can write a SQL query for me.
Exactly. So I want to dive into this and see what that actually means now, right? So once again, keep in mind that this thing, the whole point here is to have it translated into SQL and sent to the database for evaluation of these operators somewhere else. So in a server, this is the whole point of iQueryable, basically, okay? Now, you know what? I'm going to do something very simple here. I'm going to place 2 breakpoints just to drive the point home. I'm going to remove the to array at the end. So in both cases, nothing is going to happen. Both constructs are very lazy, right? This one doesn't evaluate, and this one doesn't evaluate or translate or anything. So I'm going to do an F5. I hope that the debugger will be visible enough because I don't have a lot of real estate here on my screen. But let's see what happens. So this is a building. Running. Okay. Okay. Yeah. You know what? Before this, I'll do a var x because I want to
throw away the result there.
Yeah. Exactly. Don't want to throw that away. I want to actually use the debugger to see what is the thing that we are constructing here, right? Without actually evaluating it. So let's see what that is. Oops. There we go. So I'm gonna do step over. So now x contains my thing. Note again, this has not been evaluated. I've not actually applied the where and the order by, right? Because this is lazy evaluation. If I look at x at that point, then I have something which is an ordered enumerable, okay? If I look into it, it's going to be an enumerable composed over another enumerable, and that's eventually going to be composed over that blogs thing. But these are enumerable classes. They stay enumerable, and at any point, I can call get enumerator on those enumerable and start getting the results out of that thing. And at that point, the where operator will start kicking in, applying its filter, and the order by will kick in, doing its ordering, and so on. Now, I want to do the same thing. But I actually am missing something here. If I want to put a breakpoint, I'm just going to put whatever, something like this, and I'll put the breakpoint here, and I'll remove this one. I want to show you what is actually there, how the sausage is made once again. So if I look, maybe I'm going to need a bit more space for the debugger here. So I'm going to bring this up here. So once again, the results here is this thing, which if you look at it, you will see that this is a queryable now. Now, this is where it starts to be interesting. There's a whole lot of stuff here, which we're going to go into in a few seconds, not too deeply, but the one I want to concentrate on is this thing. This queryable thing that you see contains something called an expression. This is where the fun starts. What you see here is we have something called a method call expression. And if I go into this, I'm going to drill down to this. You'll see that inside that method call expression is a method, and that method is order by. So this represents the calling of a method called order by. It is not, the method has not been called. Nothing has been called here. What has been done here is we have something that represents the calling of order by. If I continue looking inside this, so this is the method and this is the arguments to that method. If I expand this, there are two things there. The second thing is a lambda B2B name. Remember, this is this thing that you see here. You now see it in here. It's suddenly been copied into this, magically copied into the structure somehow. The first thing, the first argument is the thing to the left of the order by because it's an extension method. So we have a method call expression. Again, we just saw a method call expression. Now we have a new one, but this one is for the where. So what I'm trying to tell you here is that this expression thing that you see is basically a representation of this whole thing. Okay. Now, anybody who's worked with any sort of, if you've studied compiler at some point in university or worked with syntax and all that kind of stuff, you're aware this is not super advanced. It's pretty basic. This is what we call an expression tree or sometimes an abstract syntax tree in AST. I'm gonna help you guys out, and I want to show this on a slide. Yeah, go ahead, Arthur.
So I want to just push back a little bit on that. Like, if you're a compiler person and you understand compilers, then this stuff is pretty basic.
Okay.
Most of us are not compiler people, and expression stuff is actually pretty complicated. And I also want to bring in a couple of the comments here, because I think this is really relevant to what you've just been saying. So this is from before you just did that debugging session. And saying, well, that doesn't explain why we have iQueryable because they're both lazy. But as you were showing in the IEnumerable case, what you've built up is code that will then get executed when you do toArray. It's actual code. It's just it gets run. In the iQueryable case, we haven't built up code that's get run. We've just built up a representation of the code that you write, an expression tree, like you just showed, which shows the code that you write. It's not going to be run, as you're going to go into. We're going to basically translate that. We're going to look at it like a compiler would in a sense, but it's not going to be run. And that's they're both lazy, but that's the difference between the iQueryable and an IEnumerable, and why we have the IEnumerable.
Exactly. We had a team member who used to refer to Queryable as double lazy. In fact, I'm not sure. I mean, it's a way to look at it. You can look at it this way, right? It's lazy, first of all, in the IEnumerable sense. It's lazy in the sense that we don't invoke these operators as we're calling them. We invoke them later. It's lazy in that sense. But Queryable goes a step further and doesn't invoke them at all in the client, so to speak, right? They're never invoked as operators in the client. What we get in the end out of this whole thing is what you see here on my slide. I did do some PowerPoint just so I could visualize this for you guys. So
just quick, can we
sure.
Move that message off the screen? The one that StreamYard is showing.
Of course, yeah. No
and then
problem.
People are asking about expressions and saying the documentation is not there. We're going to go a lot more into expressions as we go through this, but we'll try and come back to that.
We are, but I do want to say one thing about this. Let me come back here. You know what? Let's stop this debugging session. It's not that important. The nice thing about the way LINQ is done is that this thing here actually constructs an expression tree for you. Now, you can construct an expression tree yourself. There's an API for this. You would do expression.call, and this is a factory method for producing exactly that method call expression that you just saw before. But that would be, let's call it, dynamically or explicitly constructing the expression trees. Whereas the amazing part of LINQ is that the expression tree gets implicitly constructed for you by the compiler. And that's the magical thing. You don't have to know anything in order to run a LINQ, to write a LINQ query. You're using the exact same code and C# that you're using for the enumerable version. You're going to use that for the queryable version. And behind the scene, that's going to construct that expression tree for you. So,
and in fact, one of the things that we see is people trying to use that expression API when they really don't need to. And it is pretty complicated to build the correct expression with the expression API. The compiler is much better at it than we are. So if you can get the compiler to do it, which is what Shai was just showing, write the code and the compiler builds the expression tree for you, always go with that. That's going to give you the best results, and it's going to be the most readable and everything, basically.
Absolutely. I actually like the, there's a comment there. Let me, maybe I can bring it up, because as long as we're doing a small break. This is a great question. So what is the point of iQueryable aside from EF? So first of all, LINQ is very old. This is not like something that was introduced 2 years ago. This has been back in the .NET Framework days. I don't even know exactly when, but in maybe .NET 4 or something. I don't know. Something like that.
3.5.
3.5, was it?
3 or 3.5, yeah.
So I do agree, first of all, that LINQ, the best case is for, translating to SQL, or, a database query is an amazing use case for this. And I'm sure that that's what the people had in mind when they designed it. EF is not the only database provider there. So there's at least 3 other, even 4, NHibernate is an ORM that has a LINQ provider, if I remember correctly. LLVLGen has a LINQ provider. There was LINQ to SQL, which was a LINQ provider. So you have various other implementations of LINQ providers which translate an expression tree to SQL. But there were also some other examples in theory. In any case where you want to express something like this, you could use a LINQ provider. For example, you could have a LINQ provider over an XML structure, for example, or you can have a LINQ provider. One interesting idea that we had at some point, you could, in theory, have an in-memory structure, and you could build a LINQ provider over that, which constructs indexes behind the scenes, right? Like to make sure that the where, so when you do a where with enumerable, what that where does, it's dumb, right? It's going to go over your entire array, and it's going to check each one. If you wanted to do this more efficiently, you could have like a whole system behind the scenes where you construct an index in memory, like a small database in memory, and then the iQueryable where would be translated to looking at the index rather than going through your full data structure in memory, like a full table scan, basically, right? So I'm trying to say this is it's an abstract concept that can be applied to many different problems, but it's true that in practice, I'm not aware of, a big successful use case except for translation to SQL.
Yeah. So when it was released, I remember LINQ to XML was one of the 3 that I remember, and I'm not saying that they weren't more, but the 3 that I remember from release were LINQ to objects, which is another name for the IEnumerable thing that we looked at, so it doesn't really use the iQueryable. LINQ to SQL, which was, we could go into the whole history of that, but it was basically an implementation of the same thing that EF is, and so EF was kind of competing product from the same company. But those were both to SQL, and then LINQ to XML, where at that time, this was before JSON and before YAML and before also everything was in XML. And the idea there is you do where whatever, and then it goes into your XML document and does the right thing there. And I actually don't even know how that was implemented, whether it uses, I don't know, but yeah, I think it's fair to say that for now, as of now, it's mostly useful for translating to databases. And of course, though, the whole LINQ to objects thing with IEnumerables is very, very useful. And people talk about the perf, and there can be some perf issues, although I know there's ideas to try and improve some of that, and there's allocation issues in some places. But in terms of just writing high quality readable code, especially in non-perf sensitive paths, it's a very, very effective and very powerful feature that I don't think we should underestimate, but not what we're particularly interested in today.
There is one other example that's not SQL, and that's GraphQL. So we've actually been discussing this a lot, and I think there's at least one, if not two, link providers for GraphQL, which means if this is what you want, not everybody wants this kind of thing, but you can use link exactly like with EF to express some sort of query, and that would get translated to a GraphQL query and sent, whatever via JSON to some GraphQL server over HTTP. So that's another example that the concept is actually very powerful and applicable to various things. Anyway, I think we talked enough about this.
Let's move in. Yes.
Let's move on. We'll do some more questions a bit later.
Yes.
So I just want to make sure that this is very, very firmly in people's heads now, right? For this query that we've been looking at, blogs where this, order by that, the representation of this in a syntax tree or in an expression tree is going to be something like this. It's if you go from so order by is called on the results of where, right? So you go from top to bottom or from the end to the beginning when you want to look at this. So the root of this tree is this order by method call, right? It has two arguments to it, right? Remember, this is an extension method. So everything that comes before is basically just the first argument to that method, right? So the second, this part here is actually easier, right? This is the lambda. This is not the exact expression tree. I simplified it a little bit. The actual expression tree is unfortunately a bit more complicated, but there's the lambda, and inside the lambda body is a member access expression. That's the b.name, and that has a b and a name. And on the left side of order by, you have where. Okay, so that's going to be the first argument to order by is another expression. This is a very recursive structure. On the left side of that, on the left side of blogs, we have the thing representing the blogs thing table into your database, right? This is the query root or the DB set in EF Core. So conceptually, yeah, that should be familiar to people. On the right side, the lambda has a body which has a greater than expression. That's a binary expression because it has two operands. And that thing has, on the right side, a constant of 1. On the left side, a member access BID, which decomposes to be an ID. So I went through this exercise to, give people a feel for what this looks like. Like I said before, anybody who's dealt with languages in programming, compiler people notably, this is the bread and butter of, this is the way it works absolutely everywhere. So at some point when you're writing C#, for example, and the compiler has to compile it, it's going to parse your C# code into something like this. It's not going to be this. It's going to be different, but the concepts are going to be the same. It's going to be this tree structure with nodes and, nodes containing other nodes, and you're going to have a binary expression, and you're going to have a method call, and anything that you can represent in C# code is eventually going to be parsed into this kind of tree structure. And the compiler actually operates on this thing, just like EF Core operates on this expression tree that you see. In fact, you should, or you can and should probably think of EF Core as a sort of a compiler. We think of ourselves in that way, and we use that word a lot. Right. So anyway, that's kind of what I wanted to say. Let me just check my notes here because I had various other things that I wanted to say. Right. I did want to show one more thing in the code before we move on. So just like we stepped into the implementation of the IEnumable where, right? We actually looked into what where looks like under the hood. So I'm going to do the same thing for the queryable where. So I'm going to do F12, and we're going to jump to a completely different place because this is a different method. It's a queryable where, not an enumerable where. So if I look at this is going to seem a little bit weird. First of all, it's very short, right? It's not a long thing, as you can see. It also has nothing to do with what you saw before, which is in itself kind of interesting. What you see here is I'm going to go through this quite quickly, and then we're actually going to see a minimal link provider just for fun. So you see we have the iQueryable, this argument here, right? And then, so that's the first argument. And the second argument is the predicate, which is basically that lambda. I'll draw your attention to the fact that this is not a function. It's an expression over a function. So this actually represents an expression tree in itself, which is that predicate. That b arrow b.name is actually an expression tree, a fragment of the expression tree that we're now composing on top of whatever came before, right?
I think that's a very important thing to understand, that even though often when you write the code, it doesn't look any different, right?
Yeah.
In the IEnumerable case where we weren't passing expression tree, it didn't look any different. But the fact that that signature that you're passing in says I'm taking an expression means to the compiler,
let's drive
preserve this as an expression. And that's why sometimes you can do something that looks like a reasonable refactoring in a language, like just extract this into, say, a method call, and it stops working in the same way because you stop now creating the expression tree and you start just saying call this method, and it becomes a black box. Evaluate this, right?
So again, if we're back to the enumerable where, you can see that this parameter is a func of t-source to bool. I hope everybody's familiar with this. A func is basically just a delegate or a function that we're passing around here. It gets a t-source as an argument or as a parameter, and it returns bool whether to return it or not, right? We're looking at where. The same thing, if we look at the queryable, it looks a little bit the same. You see the same func here, but it's also surrounded by an expression. And that's a signal to the compiler to not pass in a function, to not have actually a function here, but rather a representation of that function as an expression tree. Okay. Now, what actually happens here? What actually happens? So we go to the source, which is the queryable. There's something called a provider. That's our queryable provider. We'll see this in a second. And we call create query on it. So we create a new query over it, a new queryable to be exact. And what this does is it uses that API that we briefly mentioned before, expression call. So this creates a new node in an expression tree. And crucially, what it does is it passes it the old node as an argument. So it takes the old node before this where is being composed, the blogs, whatever it used to be. It takes it out, and then it wraps it in a new call node. Okay. And what it adds, obviously, now there's this new call node, and you can see that there's this thing, there's a quote around the predicate, which is what we added here. So once again, I want people to be crystal clear about what's happening here. What we just did is we constructed this thing here. The expression was this, right? That was the queryable that we had before. We took that out. We constructed a method call around it. We also put the predicate, which is this thing. This whole thing is what is now the predicate. And we return a queryable over this node in the expression tree, right? So what I'm trying to say to you to summarize this is not that complicated. The queryable version of where, what it does is basically create, compose an expression tree. We're constantly adding nodes on top of each other every time that we add another operator in LINQ. We're just adding another node, one on top of the other. That's all we're doing. Nothing ever gets evaluated here. This predicate here never gets invoked. Nothing of the sort happens. We're only building up an expression tree that eventually will be translated into something else. Okay. Do we have any special questions around this stuff that I'm showing here?
I think we should just keep going.
We should keep going.
General questions, but they'd be better. Let's get through some more of it first.
Okay, I'm going to do something a bit ambitious at this point, and I'm going to paste a minimal link provider. Now, this is not going to translate stuff to SQL, right? I hope people are clear on this. This is a very, very, very proof of concept, like skeleton of what a link provider might look like. So I'm just pasting this, and I'm going to show you guys what it looks like. This is just to get you to have a sort of a feel around this. I'm constantly switching between windows here, so this is why it looks a bit weird. So let's concentrate on this thing here. First of all, I have something called a myQueryable here, okay? And that implements the iQueryable that you saw. So this is the interface coming from .NET, and this is a myQueryable over T element. So this is something that we can query, and it can return any type of element conceptually, right? You can think of this a bit like a database table. Again, we can go to the database and query this table, you know, do where, select, order by, all that kind of stuff. I hope I'll be able to explain this in a way that's not too complicated. A queryable has an expression, which is what we saw. It's all very, very, very simple, right? All this is an expression that represents the expression that needs to be translated, right? It has the element type, which is what we're querying over at the end of the day, but that's not super important. And crucially, it also has this query provider. Okay, so there's a provider here as well. that the queryable is wrapping. So behind our queryable, you can think about this queryable as something belonging to EF Core, to your specific link provider, and behind the scenes it has a provider which does various stuff. For example, if I now ask the queryable to get an enumerator from it, that is basically telling the thing to get executed, right? When I come to this queryable thing, and I'm saying, please enumerate this, what I've actually just asked is, please execute this query and return the results and stream them back to me, right? This is a very, very crucial point, right? At the end of the...
This is what happens when you call toList or toArray, right?
Precisely.
Basically, toList says, okay, I'm going to create a list, and then I'm going to enumerate the thing. So it calls get enumerator, it iterates over it, puts all the stuff in the list and returns it to you. So it's like, this is how you execute it, basically.
Exactly. So exactly, like Arthur just said. And that delegates to the provider. So we're going to go down to the my query provider, which is my very minimal, provider for our link implementation. And there's basically two methods here. There's really nothing more. The first thing is create query, which you saw in the other. Do I still have this open? No. Let me go back to the where implementation. Maybe we should have this nearby, right? So you saw that the where operator, what it did is it went to my queryable, extracted the provider out, and called the create query method. So if I look at this create query method, it's all very simple. It returns a new my queryable over that expression that's given to it. This is basically a hook or an extension point in case the provider wants to do any sort of manipulation. Doesn't really matter. But what we're doing in this phase is basically just composing those nodes, those expression nodes, one over the other. What gets interesting is execute, which, as we saw, gets invoked when we enumerate this thing, right? This is where the magic happens. And here, obviously, I'm not going to actually do anything because I'm not going to write a link provider here. That's a very complicated task. But what I will do is I'm going to do just a bit of debugging here. So I'm going to do console write line. Executing query, the topmost expression. So I'm going to look at the topmost expression in my expression tree right now. Remember, it's an arbitrarily deep expression tree. It's very recursive, but I'm going to look at the thing at the top and I'm going to write out its name. And then if it happens to be a method call expression, which it is in my example, then I'm also going to tell you what the name of the method is. So this is basically something, and here is the to-do. Here's where we're actually supposed to translate the SQL, right? Which is a small task, obviously, but I didn't. I'm obviously being facetious. And then it doesn't actually return anything. Let me get to that in a second. I just want to run this, and then we'll address that question.
Okay.
So let me. I just wanna run this. So I commented everything else, unless I've somehow done some sort of error. Oh, and the code that actually runs this, I need to show you. So I'm constructing a my queryable. This is like our DB set. I'm passing an array, which is the thing which theoretically we'd be querying over, but of course we're not really doing anything here. Then we're going to compose a where, right? A queryable version of where with a predicate, and then we're going to call first or default on it. So in theory, what we're expressing here is that we want to get back the first thing that is bigger than 1. But of course, my link provider is not actually implemented, so I'm going to run this. Let's hope there's no null reference exception. Of course, there is something. Yeah, I think, I left this thing here, so I'm going to take it out. Go back up here. Okay, so what this actually worked, right? So what this link provider is doing, it's telling you stuff about the expression tree that you've constructed and handed to it. And what it's telling you is that the topmost expression is a method call expression, and the method call is for the method first or default. So this tree has 2 method call expressions composed on top of each other. First or default on top of where, on top of this constant expression here. Okay, this is basically what is happening here. The link provider doesn't do anything with it. It just outputs some debugging stuff. But you could, in theory, now start implementing this thing and do whatever you want with that expression tree. It could interpret it, translate it in any arbitrary way, do something with it over SQL or over anything else. It doesn't matter. That's your implementation of your link provider, which is quite a phenomenal thing, I think. Like it's a design that's very, very interesting. And by the way, I'm not really aware of something like this in most other languages. So LINQ, this thing which you just saw, the queryable implementation of LINQ, is quite unique as far as I know in other languages. Of course, it does exist. Enumerable operators exist by now in every language. So every language allows you to write, where this, order by this. The details vary, but this exists everywhere. Whereas this thing where you use the same operators to express SQL, that's something that is very unique to C#, and I think very, very cool. It's a very strong point of C#. When people ask me, what is interesting about C# for database access, then LINQ is my immediate response. This is like a very unique feature. And if you've only done EF Core in C#, you've never done database programming in other languages, then you don't know how lucky you are. In my personal opinion, I think LINQ is really, really awesome in that sense. It allows you to use these very basic building blocks, where and order by, which everybody knows and uses on memory. It allows you to apply them to express SQL queries, which is like an amazing thing. And you just saw more or less how that works behind the scenes. Okay, maybe let's bring that question back that you had.
Right. Yes. Sure. I mean that's basically what you've just been talking about, right? Is that it? Oh no, that's the other one. That was the first question. Yeah. So yes, interpreting the expression. So this is a complicated bit, right? This is the bit which we're probably not going to go into in detail. Sorry, I was answering some questions, so maybe you said this already, but this is where you use a visitor pattern and you have to interpret things, and this is most of the work that Smit used to do in the query pipeline. And believe me, it's
not easy.
It's really difficult stuff. Yeah.
I would say this. I'm going to show some bit of magic here that if somebody wants to play around, they can at least start. And by the way, I think we're going to do another session because this is not enough time to, there's so much to talk about. We'll probably do another session where we'll talk about how you visit, expression trees and, techniques for actually looking at expression trees and changing them and all that stuff. We'll talk about this. But I just want to show one bit of magic here. Okay. What I'm going to do, maybe this will blow some people's minds, but I'm going to do the following thing. I'm going to write. I'm going to write something like this. Okay, I just wrote this code here. And then I'm going to do like before. I'm going to do something like this. This is actually not new compared to what we've already seen. So what you see here, there's no functions, there's no link providers. This is super simple. I'm showing off a capability of the of Rasa and of the C# compiler now. Basically, what you see here, you know what? I'll start out simple. I hope people are aware that you can do this. Let's start easy, right? This is a very simple C# construct where I'm defining a delegate, okay, like a function, let's say, that accepts an int and returns a bool, just like for where, right? At this point, I can do console write line predicate, and then I can put parentheses and do 8. So I'm invoking that function which I just created up there, and that's going to write, obviously, yeah, that's going to evaluate, that's going to do mod 2, it equals 0. So yeah, it's going to give me true, right? I hope this is clear to everybody. I can run this. It's not really that interesting. If I add expression here, like we saw before when we looked at the function, that's assigned to the compiler. That what I'm interested is not in compiling this code, but rather constructing an expression tree out of it. So if I run this and I look at what predicate is, I'm going to find an expression once again, right? Like that's the whole point of what we've been talking about. I just want to show this in the debugger. So if I look at predicate now, this is now, this thing is now an expression. And you can see that there's a body with a logical binary expression. That's the equality check. And if we go into this, there's a left and the right. And the left is another binary, which is the I mod 2. So this is a way, if somebody wants to play around with expression trees and see for a given C# code, what kind of expression tree it translates into, then this is a nice way to do it. This is what I do sometimes. Like if I'm not sure, I have like some C# code and I want to see what it's going to look like as an expression tree. This is what I do. And then I look at it with the debugger. I see what the compiler has constructed for me as an expression tree. And that's my way of kind of understanding how it is.
That's what I do too. Yeah.
Exactly. After you've done this for a while, you kind of know you know what it looks like. It's not the end of the world. But even we do expressions every day in the team. It's still tough. It's still like hard to keep this in your head all the time. Do we have any other interesting questions?
We have quite a lot of interesting questions, but not specifically necessarily on this point. I mean, we can just go answer some questions if you want, and then come back.
I'll tell you what. Like my next thing is starting to talk about what an actual link provider looks like, which is EF Core. So if we want to still talk about like conceptual link questions, then maybe
let me look through here. I think most of these are more relevant to EF Core.
Mm-hmm.
Things like include, things like the difference between two-list and two-list async.
Okay.
Yeah. So let's go on to the EF.
Let's move on. Yeah. Let's move on. Exactly. We're getting ahead, like in terms of time, so we can move on. So now we've discussed what a link provider is at a very high level. What it does, it's a component that gets a query tree as input. We've gone over this part of It does its thing, right? This is the input, the query tree. It does like a whole lot of complicated stuff. And at the end of this thing, it's supposed to give us back an enumerable that gives us the results of that query tree that was executed against, let's say, the database or whatever, right? So this is basically all it is. Input is the query tree. Output is an IEnumerable. This is what a link provider does. This is what EF does in its capacity as a link provider. It does other things as well, but in its capacity as a link provider, this is what it does. Now, in order to do its job, now we're starting to talk about EF and databases. We're getting concrete. It needs to produce two things, this complicated cloud thing here. The first thing, which everybody understands, is it basically needs to produce a SQL translation of the query tree. This is not trivial. This query tree that you saw represents your C# code, but the C# code doesn't look anything like what the SQL looks like at the end of the day. Superficially, it might look like it, right? Because you have a where in C#, and that needs to get translated to a where in SQL, right? But obviously, that's where the similarity stops, right? Like in SQL, you don't have an order by composed over a where composed over. It doesn't work like that at all. You have a select expression which has different clauses. So this transformation between, a C# expression tree and a SQL expression tree, that's quite a complicated task. Believe you me, this is really, 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 really complicated. And there's a lot of work in this green cloud here to make sure that works. But that's just the obvious part of what we have to do. There's another less obvious part which we have to do, and that's the logic to read back the results from that SQL query and materialize them to you. So if you've ever worked with a database outside of EF Core, like with ADO.NET, you send it SQL, and what you get back is a table of results, right? That's a DB data reader, to be precise, which represents a streamable table of results, like a result set. There's rows and columns. But what EF Core gives you, what a link provider gives you, is not that. What it gives you is, nicely materialized entity instances, right? It gives you blocks which you can work on because it's an ORM. That's the whole point of an ORM, is to bridge that gap, the gap between tables in a relational database and objects in that's the object relational part of ORM, right? So this process we usually call materialization. All it means is basically we take that table of results and we materialize it, we dehydrate it, sometimes you say, into your own objects, your blogs and posts and so on. So that logic, that piece of logic is called a materializer. And what it does, it gets an ADO.NET DB data reader, so the raw results, the tabular, raw results from the database, and its job is to produce blog instances out of that stuff, right? So we have a server-side thing happening here. That's the SQL. And we have a client-side thing happening here. That's called the materializer, or sometimes the shaper. This process of going from the query tree here all the way to these two artifacts here, we call compilation. Okay, it really is, because it is in many, many ways very similar to what the compiler does. We don't produce, so the C# compiler produces something called IL, right? And then the JIT takes that and produces binary, actual machine code from it. So we don't produce IL or binary. We're not a compiler in that sense. Instead, we produce SQL and a materializer. But it is still compilation in some sense of the word, for sure. At least if you look at the type of code that EF looks like, it looks like a compiler in many ways. It's just a different type of compiler, I would say. So that's a little bit of that thing. Now we're going to go deeper and deeper into this. So first of all, just to drive point that home about server and client side, I find this extremely elegant. I love this personally. Let's say that our provider now encounters, there's a context blocks, and now we encounter the operator select, and we need to process it in our link provider, right? So before we saw the select, this projection here, what we had was a select star from blogs. And our job when we see that select operator is to convert that to select ID from blogs, right? That is what a select means. That is the meaning of select when it is applied to SQL. Instead of getting everything about a blog, we only want to get out the ID of that blog. So this operator, which you see here, this select operator, applies a transformation to the SQL tree, if you will, behind the scenes, which makes us produce not a star, but rather an ID. Just for laughs, we never produce a star for various other reasons. We actually write out all of the column names, but the select makes us reduce that list from all the columns to an ID. But at the same time that we do that server-side thing, we also have to change the client-side materializer. Before seeing this select, we have a materializer that needs to know how to materialize blog instances from all of these columns coming back. But the moment we see the select, we need to change that into something that instead can read only the IDs. And in fact, what that thing returns now is an iQueryable of int. It's no longer an iQueryable of blog. In other words, the select transformed the results coming out of the database, and therefore it affected the change both on the server and on the client side of this query. If you think about another operator like where is very different. Where is going to make quite a difference here on the server side, right? We're going to have to add a where clause in SQL, but it's not going to do anything on the client side because where doesn't impact the shape of your results in any way. It only impacts which rows are going to get back, but they're going to have the same schema, right? We're not going to change like which columns are coming back or anything like this. So this is for you guys to understand. In general, if you look at how the EF pipeline looks like, it's constantly working at these two levels. It's like moving forward, tweaking the SQL, tweaking the materializer, tweaking the SQL, tweaking the materializer, so that at the end of this process, those two things come out of it and can be used to actually execute the query. Do you think that was clear, Arthur? Do you have anything to,
Absolutely.
to kind of add?
I would say the only thing I'd say is, again, to think about what is ultimately happening and to say, we absolutely would not want to bring back every property of blog. We wouldn't want to do a select star from here and bring back everything and then just on the client say, throw away everything that we brought back except the ID. So that's like, again, a fundamental part of being able to write efficient queries and be fast is to be able to do these things. And there's so many different aspects to that. So like the where clause is a different characteristic, right? The where clause says, bring me back fewer rows. Like, I don't want you to bring back all the rows. And often that is even the most important thing that you don't want to do is limit the rows. But then the select clause says, don't bring me back all of the columns, only bring me back some of the columns. And both of those things are really important to handle, both in terms of either the SQL we generate and then also, as you say, in terms of how we even handle which rows are coming back in the materializer. So those things are kind of critical, and yeah.
Very much. And as you said, like perfwise, these are two operators that limit the amount of data coming back, and so they're critical. They're really critical. You should always only select what you need, both in terms of rows with where and in terms of columns with select. So it's two dimensions of limiting data, basically. To drive this point home, like what Arthur said, this is a good opportunity to say, to introduce the as enumerable operator. I kind of like it. So we're in synchronous code now. I know. In general, I never do synchronous code, but I really want to keep things simple, so I'm using synchronous code. But never mind. This is why we have two-array and not two-array async. But you should never use two-array. You should always use two-array async, is what I wanted to say. If we do this, then this is the iQueryable version of select, right? You can see this here, iQueryable, right? And that means that the select gets translated. It of course, sees it and manipulates its SQL, and therefore everything is efficient. But we could also do this. There's this operator called as enumerable. And the only thing this does in life, the only reason you would want to use this operator ever is to terminate the query in terms of until where we translate it to SQL, and to force the rest of this stuff to actually be enumerable. So if you run this query, then what will happen is EF Core will generate a select star with no, no column reduction, no nothing. The entire table is going to get downloaded here. And then this thing is going to be evaluated because of as enumerable, which is the thing that we'll call get enumerator. Remember, that triggers the evaluation and the execution of our query. And at that point, the normal select, which is an enumerable one, is going to get called, right? Now we're in the enumerable universe. So this is a marker inside of your queries. You can have, a where here, whatever be ID equals is bigger than 2. You can have, let me draw this out like this, right? So up to this select, everything here is translated, up to the, to the as enumerable, everything here is translated to SQL. Then there's this big red stop sign here that says if core can go no further, a link provider can go no further. And at that point, anything else that gets composed is now evaluated client-side. And we sometimes tell people, I'll give you an example. Let's say here you want to call some function which you wrote, right? It's a function. You have it. It's written in .NET. And you want to, let's do it. Let's do something a bit more, foo of ID is equal to something to 5. Doesn't really matter, right? The implementation of foo doesn't really matter. Yeah, exactly. I'm now answering the question that's on the board. So if I were to try this, your query would immediately fail. Now it would fail, obviously, because this foo thing is something that EF Core doesn't know. It's not one of the standard operators. It's some function that you made up. We have no way of knowing what it should be translated to, right, on the server side. So we can't translate this to SQL. That doesn't mean anything, right? And because of that, we throw a query translation failure, and we actually cannot do this. Now, if you insist that you must use this construct, you have the option of doing as enumerable, which is once again that stop sign that says up to here, translate the SQL, but from here, translate on the client. This means that we're going to bring the entire table back just so that we can call your foo function on the client side on each and every ID of each and every row, which is generally a horrible thing to do. You should never do this unless you really, really, really know that the table is going to be small and so on. But I hope it's clear. This side of what gets evaluated on the client and what gets evaluated on the server is absolutely fundamentally critical to EF Core programmers. Very, very important.
So I think there's a few questions that we should cover on that. Before we do that, I just want to point out that if you in early versions of EF Core, so basically before 3.0, if we couldn't translate something, we would sometimes do this for you automatically. So not always, but we would sometimes do an implicit client evaluation, and we would bring back all the data, and then we would do the filtering or call the function or whatever it is on the client. And we stopped doing that because it's just too dangerous. We would put a warning out, but who reads warnings, right? And famously, Stack Overflow that uses EF Core, their site went down because they did this accidentally. And we said to Nick Craver, didn't you see the warnings? Like, the first thing we do is switch off all the logs. So we didn't see any warnings. So, so we stopped doing that. And so this is the workaround. If you've got an EF2 application, which hopefully nobody has anymore because it's been out of support for ages now, but you're updating it, and you really have a place where, as Shai says, there's not much data coming back, there's not actually any perf issue, putting the as enumerable is the way to explicitly say opt into client evaluation, which is why there's no flag anywhere in EF to say opt into it, because that's it. The as enumerable is the way to opt into it. You can also do toList, toArray, any of those things do the same thing. But then, of course, you're creating a data structure which you probably don't need. And so, generally speaking, using as enumerable is better. But functionally, it will do the same thing. It will bring everything back, put it in a list, and then on the client, it'll go through the list and do the where clause. So that kind of relates to this question, have performance problems passed because IEnumeral snuck in there? And I don't know if you're referring directly to the EF doing the client evaluation, but if that is, then that's something we've changed now.
Right. So it's important to say it's not possible for enumeration, IEnumerate to sneak in there anymore, like it used to be, like Arthur said. But nowadays, anything you write on your blog is basically going to be evaluated on the server side, or it's not going to be evaluated at all, with just one exception, which is the top level select, which it doesn't really matter, right?
Yeah.
But so you can be secure in the knowledge that anything that's an EF query is always either going to get translated or it's not going to work, which is very important.
So we already answered this. I think Maurici's in the chat too, answering. Maurici's one of the people who works on the link provider on the team. But I think it's, if you do have this function, well, what do I do about it then? I think, to me, there's two answers to this. One, you actually write it in a form where you pass an expression tree of the function that EF can translate. So sometimes people are only doing this because they don't realize, and again, it goes back to the signature and everything, they don't realize that they're passing this as a black box. And actually what's in that function could be something that could be translated if you do it in the right way. It's not trivial or clear. I don't know we want to spend the time to actually show writing that, because it gets a bit ugly in terms of how you do it, but that is a plausible thing. The other thing you can do is sometimes it makes sense to have a database version of this function, so like a store procedure or a function actually rather than procedure, and you can then map that to something in the database. And so this is often true. We do this for BCL functions, for example, in the base class library very, very commonly. Like you can use, for example, string.join or something like that. And obviously, we don't know what the code is in C# that is doing string.join. We don't have an expression tree. That's a black box. But we say, okay, well, that's the semantics that we have there. Databases have functions that will do the same thing. Let's do the translation there. And so you can do that. You can also do that mapping. We have built-in functions where there isn't a BCL thing, where in DB functions class that you can do, and you can write your own custom mappings either to existing database functions or to database functions that you write. And so that's another way to handle those things. I don't know. Did you want to add anything to that, Shai?
No, it's perfect.
Okay. And then I guess finally in this kind of area, there's also an as queryable method, which I very frequently see people using, and it's absolutely pointless. Like that. Now there are, answer in the chat if you know the one place where as queryable is useful, but when doing that, it's not useful in any way, shape, or form. Like, and it's kind of a pet peeve of mine. I wish people would just stop doing as queryable. It is a queryable. You don't need to do as queryable.
Exactly. This is a no-op. This does absolutely nothing, because CTX blogs is already in a queryable. Yes. The same thing here. The result of the where is also a queryable. So there's no reason to do this ever.
Yes. So while we're not that one. Good old time. Sorry, this one. Scrolled on me. Can't believe we did it automatically. You've got to take risks. You've got to try things. Sometimes they work out and sometimes they don't. But the idea that you can always get everything right. I mean, it's not like we didn't understand the drawbacks, but at the same time, you can make arguments for it, and we won't go into that. And also, when there's more of an argument for it, if you're very immature link provider that can't translate stuff, you can make an argument that it makes sense there. I think that's what one of the things that Bryce said. It made sense in the early days, but not later. But I would just say, yeah, we tried this and it turned out that we were wrong and it was not a good idea, and that's why we changed it. But yeah, that happens, right? That's software. That's life. Okay, let's move on.
I want to at least get to the end of my my presentation. Yeah, I wanted to also do a quick step through the code, but I'm not sure we're going to have enough time for that. But that's completely fine. I do wanna talk a little bit about the actual internals here, just a bit. So the summary of where we've got to up to now is we have the query tree, we have this compilation phase, and then the outputs are SQL and Materializer. I hope that's firmly in people's minds, right? Now the problem here is obviously that compilation is very, very long. So doing this thing, producing both the SQL and the Materializer, that's not something we can do every time you run a query, because that would make it extremely slow. So what do we do when we have a perf problem? Caching, always. That's the universal answer. So ahead of the compilation thing, which is the long thing, we put something called a query cache. I'll refer to it as our first query cache because there's going to be another one. What does that mean? What it means is this is a cache which uses as its key the entire query tree. So this entire thing, which is a tree, is going to be like a cache key. That means that when we see the same query tree twice, we don't need to go through the compilation. The first time the cache is empty, we're going to go and do this whole long thing. And then we're going to save, we're going to remember the SQL that came out of that query tree. And we're going to also remember the materializer that came out. And we're going to store them in memory somewhere for you, right? There's going to be a cache there with eviction, and we're going to, you know, not make it grow forever and all that kind of stuff. The next time you run this query, we're going to say, hey, we've already seen this query tree, right? And so we're going to jump directly to the SQL into the materializer and bypass the whole compilation. This is critical. This is how EF Core can manage to be fast. Without this, EF Core would be extremely slow. So, I mean, this is trivial, right? Like put a cache in front of it, right? It sounds so easy. Unfortunately, it's nothing. It's not as easy as that, unfortunately. And here I'm gonna have to go and do a segue into parameterization, queries and parameterization. So this is also this one. I hope people like prick your ears. This is actually very useful for users. This is not just an internals thing. You have to understand this if you're using EF Core. So if you write a link query like this thing here on the left, you see that the 5 is inside that link query, right? So, oops, I mixed them around. I completely mixed them around. I somehow managed to get these. So in your mind, the arrow goes like this. The arrows are crossing each other. Excuse me. I actually I reviewed myself and I missed this. So if you put the 5 inside your link query, then what you'll see is the 5 inside your SQL. It's simple. If it's inside the query, it's going to be inside the SQL. However, if you do a var I equals 5 and then you reference the I here, then what you're going to see inside your SQL is a parameter placeholder. This is a SQL parameter, and you don't see the 5 here. The 5 is delivered separately. Now, this is a bit odd. First of all, if you look at this from an enumerable point of view, this as C# code, pure C# code, there's absolutely not supposed to be any difference between this and that. These two C#, bits of C# code are exactly identical. It is not supposed to matter if this I here is from here or from there. It actually does matter a little bit to anybody who knows about closures. You're actually doing something here that does matter. But like at our level, let's say that it's supposed to be completely
if the value doesn't change in C#,
exactly,
it doesn't matter.
Exactly. It doesn't matter. It might be less efficient though. Performance-wise, yes. It might matter a little bit. Anyway, I'm not gonna go into this on the C# side. So the point is this. First of all, it's very, very important in SQL in general, in databases, to parameterize this thing here that you see here. If you put this, if we were to use the same query, and once we would execute it with 5 and another time with 6, we'd have different SQLs. That means that the SQL database, regardless of which database it is, SQL Server or Postgres, is going to have to recompile, like replan, let's say, for these SQLs every single time. That's a very bad thing in terms of performance. So you want to parameterize so that the server actually sees the same SQL every single time, and that's a very significant performance boost. And what we decided to do in EF Core was to say that if you use a closure variable like this is called a captured variable. It's referencing something inside the Lambda that is coming from outside the Lambda. A capture variable is the signal to EF that it should parameterize this thing. And this is why you see a parameter placeholder here, but you don't see it here. So that's a very, very important thing. Parameters are also important to prevent SQL injection, but that's less important in our specific thing. We could have prevented SQL injection even while integrating constants into the SQL. So that's not relevant. This is really about performance. So I hope this point is clear to people. And when you write your queries, keep this in mind. If you're going to write like 10 times where BID is bigger than 5, 6, 7, 8, or 9, then it would actually be much more efficient to extract that thing and execute, have a different I every time, rather than embed the 5, 6, 7 inside. There's a very noticeable difference. With that out of the way, why am I talking to you about parameterization? We were just talking about caching. The problem is, obviously, if I go back, that
interesting question here on the parameterize. If it's a const, do you know what goes in the expression tree then? Because I don't know off the top of my head.
Me neither. That's a question.
Somebody try it and look at what the expression tree. There's a task for you, like Shai was showing earlier. Write it, see what the expression tree looks like.
Interesting question. Yeah.
Yeah. Anyway,
so,
moving on.
Yeah, it's a question for Rothland, right? This is not within our within our domain, right? We just get that thing. So now for the problem, parameterization causes a little bit of a problem for us. For all of this to work, we have to upgrade our architecture and add this box here, which is called parameter extraction. Parameter extraction is a process where we take the original query tree, we find those captured variables. This I here is a captured variable, and we have to extract it out. If we didn't do this, then each query tree here would have a different reference to a different closure captured variable here, because this is just how C# works. In other words, if we didn't extract those parameters, every time we would see a different query, and our cache would never, ever give us a hit. I hope that's clear. If you actually look at what the expression tree looks like for this I, you will find that this is, again, we're talking about closure. This is a field access over over a frame object, over a closure type. And every time that's going to be a different type. Therefore, we have to kind of normalize all of these. We have to make sure that all of the instances in which this gets executed actually are normalized into the same expression tree so that our cache can function properly. So what we do in this step, we go over the tree, we punch holes in that tree. Wherever we see this I, we take out the thing that's in there, we put it somewhere else, and we put inside a parameter expression that's going to be the same every single time. And that makes the query trees identical. And this is what powers this whole thing. So before we can do our actual cache lookup, we have to do this parameter extraction thing. Is that clear? Do you think, Arthur? Was that reasonably clear?
That's clear. Yes.
Okay. So we're progressively making this a little more and more complex, like the way that this works. But that's gonna be okay. Now,
so we do actually have a question about compile query that I've been waiting for this. So let me just bring it up to give.
So I have that slide coming up just now.
Oh wait, so you're not doing.
The slide is coming up. Yeah. I am gonna talk about just now.
Okay. So here's the question. How do I get the most out of compile query and compiled async query?
Okay, so I'm gonna explain this thing now. Lots of people have heard about this feature called compile queries, and I don't think anybody knows what they actually do. So this is the moment where I'm gonna actually explain what this does. So this thing is nice, and it makes our queries very fast, and the parameterization works, and all the queries, even with different values of I. So if I is 8 or 9, doesn't matter. We're still gonna get the same query in our query cache and get the same SQL and get the same materializer, and everything's gonna work well. It's all perfect. The problem is that parameter extraction takes time. So every single time you're going to run this query, we're going to have to go over the entire expression tree. They're usually not big, but it is still a visitation recursively of the entire query tree. After that, in addition to this, yeah, exactly. Now I'm going to get to this. Parameter extraction is one source of slowdown, but the cache, very, very, very well done for this current question. Caching something where the query tree is your key is not trivial. This is a normal cache. It's conceptually like a dictionary. First, we have to calculate a hash code. Okay, so what does it mean to calculate a hash code for a query tree? We have to go through most of the nodes or to some subset of the nodes and calculate the query tree. So we've already gone once, like recursively, over most of the tree. Here, we should probably improve things in EF Core, but that's the way things currently work. And then we have to implement an equality as well. So we have to go and compare our expression tree with all the other candidate expression trees that are in the cache. And that is a recursive comparison node to node to see whether there's even one single node in that tree that differs from the version that we have cached. That's a miss. So this is not, usually when you do a cache, it's over an int or a string. That's really fast. A cache over a query tree is not fast. That's something that is, like, in absolute terms, not something that is considered like very, very high perf. And because of these two things, because caching a query tree is heavy, and because parameter extraction also adds a little bit of overhead, we introduced something called compile queries. And what compile queries allow you to do is to bypass this entire mechanism as well. So it's yet another form of optimization here. But what you have to do instead is you have to manually compile. I'm not going to say pre-compile because that's another word now. You have to explicitly tell us ahead of time that you want to compile a link expression, this thing here. And this is literally what it looks like, right? This is an API ef.compile query where you're going to tell us, I'm going to run this query, which is to search for all blogs where the ID is bigger than I. And you're going to get back a delegate, a function, get blogs, which accepts a context and that value for I. And at that point, you have your holding in your hand that delegate, which you can use whenever you want. Right after compiling it, for example, I'm going to call get blogs. I'm going to give it my DB context instance and an I, 8, 9, whatever. And I'm going to call toList on that and get the results back. So this thing is basically a way to jump over these two things here, which are still somewhat expensive. Now, I'm saying they're somewhat expensive. In real life, in a real application, which is going to actually access, databases and I/O and do disk access, and all that goes over the network, this is negligible. So I don't think people now should go and run to their code and start, coding compile query all the time. That would be wrong. This makes your code much less readable and much less fun to write. It reduces maintainability because you now have to manage your delegates and access them and manage and all. That's not the way you want to write things. What you want to do is you want to do, see, that's what I'm afraid of. What I want you to understand, you should be writing LINQ queries in the normal way, and this mechanism is more than sufficient for the vast majority of cases. But if you know that you have a very hot query somewhere, and and you've benchmarked that using compile queries actually helps in a real world scenario, then you have the option of using it. But I strongly encourage everybody to not go and use this API without first benchmarking and seeing an actual perf difference.
I was answering a question. Did you talk about the composability aspect of it?
Of compile queries? No.
Yeah. Okay, so I think that's a very important thing that is not immediately obvious. One of the things that's shown up quite a lot in the questions is, when I write a query and I do it in stages, which is a very normal thing. So I might have, actually Shai and I argue about how common this is, but it's relatively, it's a powerful part of LINQ that I can say, blogs, and then I can do, if my user has added a filter, put a where clause in there. And if they need ordering, put an order by clause in there, and I can build up my query by composing over different parts of the query. Compile query, you can't do that, because compile query, we need to know the entire thing end to end. So you can't write a compile query and then put a where clause on it. You have to now, if you want both of those, you have to write two compile queries, one with and one without the where clause. And that is a significant price to pay. It can be a significant price to pay if you were to try and use this everywhere. So as Shai says, using it where you have this hot query or these couple of hot queries can make sense, but using it everywhere is really, you'll end up writing not as nice code. It's harder to maintain and everything. And in the legacy EF6 code base, and this is an example in my mind of making a mistake in the level of, well, maybe not client evaluation, but anyway, you could write a compile query and then we would allow you to compose over it, but it now became not a compile query anymore. And it wasn't obvious that happened. It just silently wasn't compile query anymore, which I think was terrible. So right. We don't do that now. We just prevent you from composing over it.
Exactly. I mean, the whole point here is to cache the SQL and the materializer, right? To jump directly to those things that are needed in order to execute a query. Yeah. So obviously you can't support composability without giving them up, right? So yeah. Anyway, profile first, optimize later. Thank you very much. That's exactly what. So once again, we run TechEmpower benchmarks. We push this to the max. Compile queries definitely show up there, and they're significant, and it's important to use them. But those are very extreme scenarios. I really, really, really discourage people from using this just because it's faster. It is not going to matter in the vast majority of cases, and it's going to degrade your code quality. So don't just do it. Profile, benchmark. Okay. Rather, I would recommend benchmarking rather than profiling. By the way, profiling is complicated. Benchmarking will at least give you like an answer of this is what it was before.
First, and then use profiling as a tool if necessary to figure out where you get the perf back.
Exactly. Okay, I want to move on. Now stuff is getting interesting. Remember, we discussed the materializer, right? The materializer is the thing that reads back the results and materializes them into your POCOs. Now, what EF Core does is this is maybe a little bit complicated, but we want absolute best perf, right? So what we want to do when we generate that materializer here in the compilation phase is we're going to co-generate a materializer for that specific query, specifically tailored to the results coming back from that query. And that's the thing that we're going to use and also cache in our cache. What this means is if we're looking at let's take a simple query. Okay, yeah, whatever, it doesn't really matter. If we take a query like where BID is greater than I, we know that what's coming out of that query is blocks. We know exactly which columns that involves and so on. We know at that point when we're compiling this query, when we're processing it, that we can generate code that's going to read that and materialize that into blocks at that point. If we were to have general code that every time it needs to read back the results, looks, okay, which are the fields that a blog actually has? Okay, I'm going to look in the model. Blog has an ID and a name. Okay, so I know I need to read back an ID, and I know I need to read back a name. If we had general code that does this every single time, that would be slow. We actually, at some point, this was benchmarked, and we saw that, that showing up. So what you do instead in that kind of situation is, instead of having general code that does this, you have general code which generates specific code that does that job, right? So it generates specific code that already is generated with the knowledge that there's going to be an ID and a name, and they're going to be an int and a string, and we're going to read them in this way and not in that way. So we basically use what's called runtime code generation in order to do materialization in a fast way. Okay, that's a.
So so the point here is, people often talk about handcrafting. It's like they say I can handcraft my query, which is one thing. And one of our goals is to be able, in the SQL generation part that we went through earlier, is to be able to generate the query that you would ideally, if you were an expert, handcraft for this. At the materialization level, we also want to handcraft it, essentially. What we want to do is write the code, as Shai was saying, that is handcrafted to that particular result set that's coming back. It knows that this thing is nullable or not nullable. It knows that this is a type of int, and so I don't want to box it into an object and then say, oh, what type is it, and then send it back to. No, I want to take the int off the wire and put it in to the class without doing any kind of conversions, without looking up any metadata about it, because we know all that. We know all that up front, so we can use our upfront knowledge of the model and the result shape and things that are coming back to handcraft code that will be as efficient as possible. And that's basically a fundamental part of EF being virtually as fast as Dapper in for example, Tech and Power Fortunes that came up on the chat, is that we handcraft this code. We're not doing like general things. And it's also, I think a place where an ORM has generally, or a fairly complex ORM like EF has an advantage over something that is perhaps a lot simpler, but basically just goes through and says, oh, if it's this, then do that. Else, if it's this, that's simple to write. It's easy to understand, but it's not nearly as fast as having this very directed, generated code for it. And that's a real advantage in terms of using something like EF to do this.
I wanted to show like just a very simple example of what that looks like when you want to, co-generate something at runtime. So interestingly enough, we're going to go back to those expression trees that we talked about before. It's the same thing. We're going to use expression trees to express what we want to achieve. But instead of translating them to SQL, what we're going to do is actually compile them to IL, to actual .NET code, right? So it looks like this. We've seen this. I just wrote this code out, right? But instead of, so you see there's an expression of a func of, and this is the code in question. You can call compile on it. And this is a thing that goes to the compiler, gives it this expression tree, which could be a very, very deep and complicated construct, basically the EF Core materializer. And at that point, what we get back is a delegate filter, which we can now run. Remember, I don't know if I still have this code here. Yeah, I do. So if remember, I showed this thing here where we did this with the func. This is basically the same thing as this, except that here we first build it up as an expression tree, and then we instruct the compiler to compile that expression tree into actual .NET code, which we can then run. And this is what EF Core does. This is literally what happens whenever you're running, you execute a query. It's going to make up a big expression tree, which knows how to read back the results of that query, and then it's going to compile that thing. And then that is going to be used every time you execute your query. And that is the thing that gets cached, crucially, right? So this is, again, where the query cache is so important. If we had to do this every single time, produce an expression tree, compile it, these are very, very heavy activities. So all we have to do is do it once, because we've already cached it based on the query tree, and then we've got that delegate after compilation, and we can just pluck it out of the cache and bam, just run that query super fast. So this is how things work. One last complication. I know we're almost out of time, so questions? Okay. Arthur, I think we're. Oh, okay. I think we lost Sync for a second. To go through. Okay, so I'm going to try to breeze through this, although maybe this is going to go over some people's.
My machine. Sorry.
Okay, no problem. So I'm going to keep going, and Arthur's delayed a little bit. So we have a problem with SQL. SQL is tricky around nulls. This is the last complication in my diagram. You'll see. There's a particular thing with SQL and nulls. Anybody who's used SQL knows about this. So look at these two things. I did it again. I messed this up. Sorry, I should have reviewed more carefully. So on the left, we have string question mark s equals foo, and then we put s. And on the right, imagine that instead of foo, we have null. This was the point here. On the right, we have null, and on the left, we have, or maybe it's the other way around. I don't know. So if we want to translate this to SQL, unfortunately, we have to take into account the nullability here, because for any non-null thing in SQL, we just do where name equals that parameter. That's fine. But with null, we have to use the is null operator. So there's a very special way in SQL to ask if something is null. You can't use the equality operator. That's just how SQL works. I'm not going to go into this because that's not what we're talking about here. This is a very fundamental design feature of SQL. But unfortunately, what it means is that whether this parameter is null or not affects which SQL we have to send to the database. I hope that sentence that I just said is clear, because it's not trivial. The null or not null of a parameter is going to affect the actual SQL. If we could have the same SQL and just send the same, null or not null in the parameter, we wouldn't have a complication. Then everything would be perfect. But life isn't perfect for us. So that basically breaks down our mechanism here. If you look at this, right? We've extracted the parameters, and then we do the query lookup here in the cache based on the query tree after parameter extraction. But if we've extracted the parameters, then we don't know whether they're null or not, and we can't have the same SQL for both cases, right? So this breaks down our design. So we have to add another thing, unfortunately, and make this diagram a little bit more complicated. Yeah, that's what I said. We can't just cache on the query tree. And this is the final diagram. This is the end. It looks maybe a bit more complicated, but it really isn't that bad. At the end of compilation, we don't get SQL and materializer. We do get the materializer, but what we also get is a second query cache. That's why I've been calling this a first query cache. The second query cache, its key is basically whether each parameter is null or not. So it's like a set of flags. The first parameter is null or not, yes or no. The second parameter is null or not, yes or no. That whole thing is basically our key. We basically encode the nullability of all the parameters, and that's a key for us. And then we do the exact same thing. The first time this cache is empty, so we're going to go into a second phase of compilation, which I'm going to call here parameter-aware compilation. This is relatively shorter, and specifically what happens here is the actual SQL generation. So SQL generation happens here after we've already passed the cache, which knows about the nullability of parameters, right? That means that in this phase, we can know for each parameter what its value actually is. Is it null or is it not? Which means that the SQL can be tailored now based on whether the parameter is null or not. The end result is the SQL. The second time that we come here, the cache for this already contains an entry for a parameter that's null or not null and so on. So we can jump directly and get the SQL. So to summarize, you have a multi-layered caching system with an EF-Core query pipeline. This is fairly fast at the end of the day, right? At the end of the day, when the system is already hot or warm, so we've already executed the queries, after startup, we get a query, we do the parameter extraction, we do the query, and we get a hit. We jump directly to the second query cache, at which point we extract the query cache for the nullability of the parameters. We check that, and we get a hit as well. At that point, we get the SQL. We have the materializer in the SQL. We can execute the query. So we just do these two jumps and jump over both the first part of the compilation and the second part of the compilation. But of course, when a new query comes, we have to go through this whole thing and do all of this journey on the very, very first time.
Okay, so there's a few questions about this thing that I think we can is a good point to go into those now.
Very good point.
Okay, so you just answered this one basically, which is does it get compatible every time I run?
Wonderful question. So today the answer is yes. However, maybe some people are aware that for EF-Core 8, we're currently engaged in a native AOT experiment, which would basically move this whole thing. Exactly, it would move this whole thing out of runtime. You would do this ahead of time. And you would, when your application starts, these caches will magically be preceded with all of your queries. This is like where we're trying to get to. And that means that your application startup will be far, far faster because you no longer have to compile stuff at runtime.
So then also, this is a question that always comes up. Cache eviction, what happens?
Right. So the cache here has a pre-configured maximum, which, if I remember correctly, is 1,000 queries. I'm not completely sure anymore. I think it's 1,000 queries. There's it does an LRU, if I remember correctly. So if you need a new query and your cache is full, it's going to eject the one that was least recently used, if I remember correctly. You can tweak those numbers if you want, but basically it generally works kind of okay. So we're going to cache 1,000 queries globally. By globally, I mean in your singleton. So in a singleton context, let's say globally to make things simple, right? Your application, assuming it has just one service provider, 1,000 queries are going to get cached by default. As long as you're not doing something by accident where you're generating a new query each time, and I would love to talk about it, but we don't have enough time. There are certain erroneous patterns of dynamic query generation, which can make this break down in a very, very bad way. As long as you're doing the right thing and you're doing it simple, you're not going to have it's very rare to have like 1,000 completely different query shapes and I'm not talking about parameters. Once again, parameters are out of this picture, right? Like completely different trees. It's very rare to get to this. So everything tends to just work.
So specifically about the nullability thing, there's a question here about using nullable reference types. So, this actually happens now in the sense that the model knows whether a parameter or because of it knows in your model whether a particular property is nullable or not, which nullable reference types are used as one of the ways to determine that. It knows whether or not this thing can even ever be null. Exactly. And so in that case, that already happens.
So I'll say, to make Arthur's point crystal clear, what you define in your model for a property affects what kind of SQL we're gonna generate. So if a column is nullable, generally you're going to see far more complicated SQL because we have to take into account the case where it's null. So don't make your columns nullable unless they need to be. Is basically what I'm saying. If you don't need to hold nulls there, tell us that you don't need to hold nulls, and we'll generate better SQL for you. Now, NRT only comes into the picture for configuring your model for that property. That's it. You can also configure your model directly via the Fluent API, regardless of NRTs. NRTs are just a signal to EF-Core that property in the model should be nullable or not. That's all it is. Otherwise, NRTs have absolutely no role in EF-Core's life.
So you can put a required attribute on a property, or you can call is required in the API, and it will do the same thing.
Exactly.
So this is something that is definitely relevant here and relevant to the AOT. If I have 4 reference type parameters, will that explode? And then related to that, if I invoke it with its 16 different types,
If you go back to so first of all, yes, exactly. If you actually run it with the 16 different types, then that may happen. And again, it will use the normal caching rules and eviction and LRU and so on. I just want to say this has nothing to do with reference versus value types, because the word reference is in there. Once again,
that's true.
The question, you could, yeah, I mean, you can have a nullable value type. It does, okay, the parameters here we are in the .NET side of things, so you can also have a nullable value type, and that's a null as well, right? So in that sense, anyway, we can move on.
Yeah. Okay. So we talked about that. Okay. There's one
we
thing
are at an hour and a half. I'll just
I
say.
know. So we're gonna just go back and answer some of the more general questions as we can. And yeah, let's just do that. I probably won't get to them all. I'm sorry if I don't ask your particular question here, because we've had a lot of questions. So appreciate everybody's asked them, but we'll try to cover some of these things. So let's see. Let's go to. So just quickly. So it was clear about the const thing that people didn't know, or at least some people knew and some people didn't know, but somebody did try it. And no, that's the wrong. Just checked. Here we go. They just checked, and it's the same as using a literal. So
Okay.
yes, constant. It doesn't get parameterized the same, which makes sense. It's the way it should be, I think. On client evaluation, breast breaking change, you all did. Yeah, this is why we have to do some breaking change, even though they can be painful sometimes. It's got to be a balance. Let's see. Yes, the querying large strings and varchars, that's the SQL client issue. Go put your vote, thumbs up on the SQL client issue, so we can. Not that it's a difficult problem, but that's a whole other stand-up. So let's see. Try to find the most interesting ones here. Okay, so here's a fairly simple one. If I had 2 columns to select, is that also executed on the server? Yes. We'll bring back the 2 different columns that you asked for, or however many you asked for, right? So that's again about being efficient in what we bring back. Oh, this was a good question. How does the database provider factor in to all of this? Which is something Shai knows a lot about.
In principle, this diagram that you see in front of you is exactly the same, and the database provider doesn't figure into it. Where it does obviously come into play is within those boxes, compilation and parameter-aware compilation. So the database provider can insert, there's various ways to insert functionality into these green boxes, which are black boxes in this, in this specific thing. We don't know what's going on inside, because that's not what this stand-up is about. Obviously, this is where everything gets customized. For example, Postgres needs to generate different SQL than what SQL Server needs. So in this parameter-aware compilation box, somewhere is something called the query SQL generator, and the Postgres one is obviously customized and overridden and so on. But that's only within these 2 boxes, compilation long and parameter-aware compilation short. Aside from this, it is exactly the same thing. I will say one thing. EF-Core is not just for relational databases. It's not just about SQL. We also have Cosmos and potentially, and not potentially, and other providers which are not at all relational. For those providers, everything I said about SQL is irrelevant, and you don't have a second query cache because there is no SQL. And this whole problem with nullability of parameters is a SQL problem. So another database will not have it at all, right? So with other providers, the diagram is effectively going to be this, okay? Because you don't have that specific problem of SQL. You're just going to have whatever the provider does in the materializer and so on. I hope that answers that question.
Absolutely. Okay, so let's see. Let me hide that one and from a friend Georgie here, pointing out that there are libraries that you can use to help you build expression trees dynamically if you need that. Although I would say, again, use the compiler if you can, but you can use some of these libraries to help. One thing I wanted to just mention about the materializer thing, you showed the code, Shai, on your screen about how, you said, if I write this and then it produces a func, that's the same thing as what the materializer doing. But of course, the difference is the materializer is really doing that dynamically. It's like looking at the model metadata and the query shape, and so I wanted to just very quickly let me add this to the screen. So this is a part of the materializer. This is called the entity materializer source, and you can see it's basically doing these.
Everybody
things,
cover your eyes.
It's doing these things that we talked about, right? It's when we build up, this is kind of a bunch of functions that call into these other things, which do things like create member assignments and add that to a list of block expressions, and then one of the interesting things is
there was a nice if then else up there.
Yeah,
I think that's a nice one, Tishan.
This is a good one. So this is about materializer interceptors. So we want you to be able to intercept we did query interceptors, I think, in EF7, and that's a valuable feature. But if you're not using them, it should have a zero perf impact, right? And so basically, this is only going to get called if you've got an interceptor. We'll only put this into the read. So there's no code that runs at runtime and says, if there's an interceptor here, do this. Like, if there isn't an interceptor, we don't even have that code there. But if it is, then we create these block expressions, and then we execute, create new things, new objects, bind them to things, call methods of them, and we're basically building up this big list of things, and then if there are properties, do this thing. If they're not properties, do a different thing, because we know whether there's properties or not, so we can do different things. And so this is using expression trees, right, to build this dynamic code. And it's to me, this is the funnest part of EF. I love it, but it's not easy either. And then at the end of it, we end up putting all this stuff together and creating a lambda, which essentially, this is only used in a certain code path, but takes some information and goes and puts your query result out the other end, and that's essentially how it works. So anyway, so there's that. Okay, so we talked about interpreting expression trees. So there's a question here about how we handle new C# features, and that's kind of interesting because there's really two different parts to this. There's things that actually change the generated IL or the generated expression tree, and things that don't. And a lot of things like init are handled by the compiler differently, but as far as what EF sees, it doesn't actually make any difference. It's the property setter is in it. It's a setter. We can call it. We don't care whether it's in it or not. Required is a bit different in the sense that it actually doesn't necessarily let the compiler doesn't let you actually do these things. So it's not just like a warning, and it's not something you can necessarily work around if you're trying to generate the code from AOT. And so for the AOT stuff that we haven't gone into detail here, that some of those things can be difficult, because when we're dynamically compiling the code, again, we don't care whether required is there or not. It doesn't matter. It's a compiler thing. The IL we generate is the same. Expression tree generates the IL compiles, it's all fine. We don't care. But if we were to try and do that in an AOT ahead of time as C# code, now we do different things, That's a topic probably for another stand-up, but it's a very interesting intersection between language features and link. Let's see, we're gonna have to skip some of these questions.
We're really over now,
way over, but okay, so one final thing there's always the other side of the fence. This person really loves client-side evaluation, so it's yeah. The like I said, you can see. I think general consensus is it was a bad idea, but it's not without its value that people see as well, as is always the case in software. So anyway, I think we got to the right place. As enumerable is a fairly easy and very explicit way of saying I'm okay with it here.
Yep.
Okay. Good stuff. There's always more stuff we can go into here. Give us some feedback, tweet at us, or there's a link on GitHub for pinned issue for providing suggestions. What would you want to see? Do you want to see more about SQL generation and the expression visitors? I'm throwing Shai in the deep end here now, saying you can do that one.
If enough people want to, then I'll be happy to do another stand up. Like that, we would go into the boxes, basically the compilation and the compilation boxes. Then we could do this.
Yeah. Anyway, so let us know, and thanks for all the questions. That's great, and I'm sorry we didn't get to answer all of them, but yeah. I guess we'll say goodbye for now then, and we'll do another one of these coming soon. Thanks everyone. Bye.